Good evening, everybody. All right. Good evening, everybody. Welcome to the Hardware IoT DSC program. Today, we'll be talking about introduction to microcontrollers. Okay, so let's check the outline of today's lecture. So we're going to give a brief overview of what microcontrollers are. We're going to talk about the features, their application areas, and why would you want to use them in a product. Then we'll also show you ways of getting started. So let's begin. So what's a microcontroller? A microcontroller is an integrated circuit that is designed to perform specific tasks. Actually, you can think of it as a type of small computer. It has a dedicated function. So in these two images, we can see there's a long rectangle, a black rectangular box with some legs. So this is an example of a microcontroller. It's a very small device. And on the right, there's a flat chip. It's also another microcontroller. So these devices are very small and they are designed to perform specific operations. So let's look at their features. A microcontroller has memory. It has a processor, inputs and output ports, and it has peripherals. So let's explain each of these features. Let's start with the processor. The processor is what allows the microcontroller to handle data. And the data is stored in memory. Now, for the input and output ports, they are just ways for the microcontroller to interact with the external world. So let's give you some examples. Let's give you some examples on that. I'm coming, should be able to share this screen. All right. So a very simple example is the airbag deployment system of a car. The airbag deployment system of a car. Airbag So basically, a microcontroller can be found in a variety of devices. And in a car, the microcontroller inside, well, there's a microcontroller inside that handles the release of airbags during car crashes. So how does it do it? You know, we already said earlier that the microcontroller has processors, it has memory, it has inputs, output ports. So how does it handle airbag deployments in a car? So let's represent the microcontroller with a box. Let's say MCU for microcontroller units. And then there are sensors. There are sensors. And then there is the airbag system. So the microcontroller is connected to the sensors and to the mechanism that will trigger the airbag. So data is sent from the sensor to the microcontroller, and the microcontroller sends data or signals to what will trigger the airbag. So whenever there's a car crash, the sensors basically send data to the microcontroller. And since it has memory, it can store the data. To now act on the data that has been stored, the processor performs calculations. And the processor can then make decisions on whether the airbag should be triggered or not. So the processor sends the appropriate signal to the mechanism that releases the airbag. Now let's give another example of how microcontrollers are used in practical cases. Let's say we want to control the temperature in a room. So let's say temperature control. So let's assume that we don't want the temperature to exceed 30 degrees Celsius. That's like our threshold. We don't want the temperature in the room to exceed 30 degrees Celsius. So we have to measure the temperature. We have to measure the temperature in the room and detect if it reaches the threshold. So if the temperature exceeds this 30 degrees Celsius, we need a way of regulating it. So let's assume that we have our microcontroller. I'm writing MCU, microcontroller unit. And then we have a temperature sensor. We have a temperature sensor. And then we have something like an air conditioner or a fan. So basically, what happens here is the temperature sensor measures temperature. And since it's connected to the microcontroller obtains the data, the temperature that is being read by the sensor. So the data is stored in the microcontroller's memory. So what the microcontroller does is, okay, the data has been stored. The processor now makes decisions on whether the temperature has exceeded the threshold or not. So if the temperature exceeds the threshold, then the microcontroller needs to activate the air conditioner. So data goes into the microcontroller from the sensor, and the microcontroller sends data to the air conditioner. So the sensors are usually connected to the microcontroller via the input ports, and the microcontroller is able to control devices like the air conditioner in this example and the airbag mechanism in the previous example. So it's able to control those devices using the outputs ports. Sorry, the writing is a bit bad. So that's just to explain what I stated earlier. If we go back, we said it has input and output ports. So it's able to connect to the external world via the input and output ports. So it receives data or signals through the input ports, and it is able to control devices through the output ports. And it has different peripherals, which will be discussed in oncoming weeks. But for now, we don't need to go deep into them. So let's look at more application areas of microcontrollers. So we have in consumer electronics, we have in medicine, smart devices, robotics. All right, so the first device we have here, this one I'm moving around, is a calculator. So we're all familiar with the calculator. So there's a microcontroller inside. Basically, in order to make you appreciate this, let's use the same explanation we've been using. So let's go back to our drawing board. So this time, okay, initially we talked about airbag deployment and we talked about temperature control. So there are sensors, and then there's the microcontroller, and then there is the output device. So this time around, in the case of a calculator, what you have is the microcontroller, you have the buttons. Okay, let's just call this the buttons. And what you have as your output is the display. The display, that's the LCD, yeah, the display. Okay, maybe not an LCD, but a display. A display. So the microcontroller inside the calculator receives data from the button. So when you press a particular button, a certain data is sent to the microcontroller and stored in the memory. So the microcontroller acts on the data and sends the appropriate data to the display. So if you press 1, your microcontroller knows you've pressed 1 and sends it to the display. All right, you should display 1. So just like we've been explaining before, the buttons are connected to the microcontroller via the input ports. And the display is connected to the microcontroller via the outputs. Okay. I hope we can hear me properly, and I hope we understand what I'm saying. Please signify if you can, if you understand what we've been discussing. All right. Okay, that's 2 people already. All right, so the second device we have here is a special, it's called an electrocardiogram. So it's a device that doctors use, to monitor the heart rate. So just like all our examples, this device is able to pick up signals from the heart. It checks if the heart rate is normal. So it picks up the signals from the heart, and you know that to link the heart to this device, you need sensors, right? And so the microcontroller inside this device is connected to those sensors through an input. And then it also has a display to show us whether, to show the doctors whether the heart rate is normal. And then you have a digital watch here, also makes use of a microcontroller. And then you have a drone here, also makes use of a microcontroller. So we've seen different application areas of microcontroller and their basic features of processor, memory, the ports. So why would you want to use a microcontroller in a product? Probably you want to develop something, you want to make an electronic device or something smart. So why would you want to use a microcontroller? Well, microcontrollers, they are power efficient. They are designed for specific operations, so they consume less power. So if what you want to build is to run on batteries, then using microcontrollers is a very good idea. Then low cost. The good thing about microcontrollers is the technology used in making them is such that a large quantity can be produced for very small amounts. So adding them to your designs is going to be a very good idea. Then the small size actually helps in making products that are very small. So these are some reasons why you will want to use a microcontroller in a project. So how would you get started? How would you get started with a microcontroller? In order to work with a microcontroller, you need to program it. And we said earlier that it has memory. But initially we said the memory was for keeping data received from sensors before the processor acts on it. The thing is, that's just one type of memory. That's the RAM. There's another memory that stores the programs. And the programs that are very popular, the popular programs, or the popular programming languages that are used for programming microcontrollers include C, C++, assembly. So these languages, you use them to give instructions to the microcontroller to do certain things. It could be to read from sensors, it could be to check the time, things like that. So you use your programming languages to instruct them, and the programs you write are usually stored in the flash memory. So in order to actually program, you need an IDE. This is just an environment where your code will be written. And I have a simple example here. This is just a simple diagram. So here, it's a code is written to turn an LED on for 1 second, then turn it off. So basically, that's the program. And the specific task being done in this case is just to blink the LED. So the IDE is where the code is written. And this is just a simple code to control the LED. So if I may ask you guys, the LED that is connected to the microcontroller, is it connected via an input port or an output port? So anybody can answer. So the LED that is connected to the microcontroller, is it connected via an input port or an output port? Okay, nobody has said anything. Or you can put the answer in the chat box. Hello, can you guys hear me? Oh, no one is responding. So I said this basic, inputs, I'm seeing inputs. Oh, someone said outputs, yeah. Yeah, output is the correct answer. So I'm going to demonstrate why, or explain why. So let's go back to our rough board. Okay, so you know, in the beginning, we were explaining different examples of application areas of microcontrollers and what they actually do. So we talked about sensors, that they are connected via the input ports to the microcontroller. That's for the microcontroller to receive data. But if the microcontroller is to control something, it will be through an output port. And in the calculator example, the microcontroller had to send data to the display through an output port. So if you want to turn an LED on or off, you basically be controlling the LED with an output port, right? Yeah. So okay, let's just give one more application. Maybe you have a smart pump. So if water gets filled up in a tank, you need a way to detect that the tank is already full. So you need a sensor, right? A sensor. So once the sensor detects that the tank is full, the microcontroller will then process the data that the sensor will give to it. And the sensor is basically just going to tell it that, all right, the tank is full, so you need to do something. So what the microcontroller would do is to stop the pump so that water doesn't overflow. And to stop the pump, it basically needs to use an output. And the output basically is just to tell the pump to go off. So it just sends the message to the pump that, all right, go off. We don't want the tank to overflow. So I hope we understand the, hello? Hello? Did you guys understand the analogy? You guys understand the analogy? All right, all right. Okay, are there any questions? Are there any questions? Does anyone have any question? No one is saying anything. I should be expecting questions. I'm actually expecting questions. You know, we've been talking for a couple of minutes and questions should pop up. Hello? Oh, well, no one is saying anything. But I hope we've been able to gain a thing or two. At least now we understand what microcontrollers are. We understand their basic features. So let's go through the slides again. Okay, no question from testimony. Okay, no one is really saying anything. Wow, that's interesting. No question. All right. Okay, so this is just everything. The overview, we talked about what microcontrollers basically do. And in all the examples we stated, the microcontroller was performing a specific task, which was to receive data from sensors or buttons through input ports, and to control devices like pumps, airbag systems, LEDs, displays using the output ports. And the memory was to hold data and also to store programs. And the processor was basically performing the calculations, making decisions on when to control the outputs given a certain input. So we saw the application areas and why you should use them in a product and how to get started. So in the upcoming lectures, you're going to be put through actually programming the microcontroller. So you would actually be given information on that, but it will be in the form of a simulation, but still it will be very identical to doing the real thing. So there are no questions, still no questions, but okay. I think we can call it a day. We've been able to discuss the introduction to microcontrollers. I'm actually thinking of giving you guys an assignment. Okay, yeah, there should be an assignment. Assignments to show that we appreciate this basic intro. So let me write it down. Oh, okay, maybe not writing it down, but yeah, a new assignment should be given. Okay, yeah. So you're going to this image will be sent to the group together with the recording. But the assignment basically is, okay, we have a situation whereby, okay, this space should be enough for the assignment. So you have the microcontroller. You have a microcontroller. You have a sensor that measures time. A sensor that measures time. That measures time. And then you have a display. So let us know, okay, the sensor is connected to the microcontroller through which ports? Is it inputs or is it outputs? And the display is connected to the microcontroller through which ports? Is it inputs or is it outputs? So that's what we want to know. And the data from the sensor, which memory is it stored? Is it the RAM or is it the flash? So those are the three questions. So thank you all for joining. If you didn't get the question, I will send it to the group again. I'll send the assignment to the group. So thank you, everybody. I think we can end the meeting here. All right. Good day.